So here we go again. I'm going to do two different equations. They look very, very similar. Um, one's x over y and one's y over x. I just want you to see them both. Neither of them are all that challenging, but I want you to see how we go through. Again, these are separable differential equations. Our goal is to set up an equation that says y equals something, and we are going to get rid of the dy dx. Like, those are our big goals. So separable tells us step number one, we need to separate. We said last time the idea is multiply both sides by dx. So we're going to multiply both sides by dx. Great. I need to move the y over this side, so I am going to multiply both sides by y. So I'm just going to say y dy equals x dx. We have separated. All my y's and dy's are on one side. It's all being multiplied together. My x's and dx's are on the other side. They're all being multiplied together. That means I am ready to integrate. So I'm going to integrate both sides of this. The integral of y. Do we remember what that is? Well, this is just y to the 1. This is one of the easy ones, right? So it's going to become 1/2 y squared. We need the plus c, but we'll just save that until later. And the integral of x is 1/2 x squared. And there's my plus c. So now I've got my plus c, 1/2 y squared, 1/2 x squared. Great, life's good. I need to solve for y. My goal is to get y by itself, if at all possible. In this case, it's pretty easy. I'm going to multiply everything by 2. When I do that, that goes away, and this c really becomes 2c. But 2 times just a constant is still just a constant, right? So we just did this just basically to go, right? Because 2 times a constant is still just a random constant, so we can just call this same random constant just c. So we have y squared equals x squared plus c. I guess I could take the square root of this. I would have to be a little bit careful because we want to make sure we preserve everything about it. So we want to say that it's going to be the positive and the negative root of this part. So now we know that y is plus or minus, so it's actually two different equations, the square root of x squared plus c. Be careful here. Some of you might want to go, oh, I can take the square root of both pieces. We can't do that. We just absolutely cannot. You might remember Pythagorean theorem and all those times that I was like, no, you're not allowed to do that. We're not allowed to do that. So we're done. That's the end of the problem. Great. Any questions? You can't ask them. Anyway, so we're going to try. That was my attempt at humor. I apologize. We're going to attempt to solve this one. Step 1, we're going to separate. I'm going to try to do it all in one step. I'm going to multiply everything by dx. I am going to divide both sides by y. So I am quickly going to get to 1 over y dy equals 1 over x dx. Great. Now, because I've separated it, I can integrate it. We should, at this point, remember that the integral of 1 over y dy is the ln of the absolute value of y. And same thing is going to happen here. It's going to become the ln of the absolute value of x plus c. Great. We want to get rid of the ln if at all possible, so we're going to raise everything to the e, or e to those things. That's going to give me the absolute value of y equals, from before we might remember that this can be broken up to this. I'll do it in 2 steps. To that. And we should remember, well, these are just inverses of each other, so that means it's just absolute value of x. Whoops. So the absolute value of y is the absolute value of x times e to the c. Well, e to the c is just another constant. So let's call it c this time. We could call it a, we could call it whatever. Sure, it's still c. So we have the absolute value of y equals the absolute value of x times c. So this is always positive. This is always positive. If this is always positive and this is always positive, this has to be positive. So we could do something like this if we wanted to. I would accept this as your answer, but if c is greater than 0, then y equals cx. So that's our equation. There you go. I'm going to do a couple more that are more challenging from here, and yeah, thanks.